is we're going to have a table in here, which is going to be an array of nodes. So private node table. There's our table. And then what we'll do in this one is in the constructor. We'll set that up. Helps you spell it right. And here we'll say there's our table. All done. Now we need a node that has some piece of information in it. Now one of the ones that we can do with this guy is, because we're playing around with him, we can add a couple interesting things here. We'll say private string is data and private int is key. So now we have a key and the data inside here, and then we can tell this thing that we want it to generate the getters and setters for, actually we're not done yet, we need one more thing, don't we? It's got to be a node, it's got to be a self-referential object. So we can add the getters and setters here for all three of these. And there's our node. So now we have a node that we're going to be able to use for our chained hash table. Going back here, now it's basically pretty straightforward. Now because we have that key in there, it's going to add a little complexity to it. So what we'll do is we'll say our add function is going to look like this. It's going to have int, key, and string data. What we're going to do inside here is we're going to hash on the key and then install the data. So what we need to do though is we need to know whether or not that thing exists in here. But what we'll do is we'll just write our hash function first. And we'll hash on key. Table.length mod no backward. Let's do it the other way around. It'll be much more useful to do it this way. Just thinking out loud here. All right. So now we have our hash function, and so what we want to do here is, the first thing is, let's write the search before we do anything. So we're going to have two searches. We'll have the public Boolean search, and then we're going to search for int key. We're just going to return the key. Now, that's just going to search for it. And once we have this inside here, we're going to do an internal search. For the key. But what we're going to do is we're going to say bucket equals bucket not equal to fail.
You also document the within key.
Yep. Alright, so we need fail. Put that in here. Private, static, final. Int fail equals minus, I don't know, 500. All right.
You want us static or?
Doesn't matter. Static means it's shared by all of them. It's just fail. They'll all use the same one. All right. And then we need an internal search. Public, boolean, no, private. Sorry. Private internal search for. Now, think about this for a second. If we return the bucket that the chain is on, we're still going to have to search through the chain in order to find it. If we return the node, you could change the data in it, but you couldn't delete it. If we return the previous node to it, then you could delete it. Wow, what a pain in the butt, huh? What are we going to do? Shall we return? Yeah, let's just return the bucket right now, and we'll figure out what's going on. And then you can go to there and do whatever you want with it if you're so inclined. In this case, what we'll do is we'll hash it. Int bucket equals hash of keys. Key. Alright, so now we have that, and then what we're going to do is just basically scan through it to see if we find it. Right? So node n equals table sub bucket. While n is not equal to null. If n dot get data, get key, is equal to key, return bucket. We get out of the while loop. Well, actually, before we do that, we should probably go n equals n dot get next. We get out of the while loop. Return fail. So this was how we search for this guy. So now we can search for it. Everything is good so far. Now, if we can search, we can add, right? Because if it exists, we don't want to add it. So what we'll do is we'll go in here and say public add, and then we want to pass in 2 pieces of information. Int key string data. First thing we want to do is search for that key to see if it exists. So what we'll do is we'll do an internal search. If bucket is not equal to fail, we fail, which is kind of weird. Because if we search for it and we found it, we fail. So if it's not equal to fail, return false, because you just tried to add it to something where it already existed. All right, now let's find a bucket for it. There's a bucket for it. We're reusing the bucket that we had above. Now, we know it doesn't exist, so we need to add it to the chain that is there. Now, there's a bunch of different ways we could do this. We could add it as a queue. We could add it as a stack. Stack's by far the easiest, right? So what we just say is node n equals new node. And set data is equal to data, and set key is equal to key, and then say and set next is equal to table sub bucket, and table sub bucket is equal to n. And once that's done, how's that look? What's that?
Just be inside of parentheses and returning it after nothing.
Oh, yeah, yeah. Yeah, that probably would help. Duplicate method. Oh, yeah, right here. Where do it? Oh, there it is. All right, so now we can add stuff to it. Does that work? What are we doing here? It says, find a bucket. If the bucket's not equal to fail, it already exists. Otherwise, we find out what bucket it's in, create a new node, add it to the head of that linked list. Pretty straightforward. The delete, yeah, it involves prev and cur and all that kind of stuff. But this one, there's no previously used, there's no, never used, none of that stuff exists. It's already there. Now, yeah, let's do the delete. Now we have a pretty much complete example. All right, the delete goes as follows. Int and public boolean delete int key. All right, so what are we going to do here? We're going to search for it, right? If we find it, the internal search will give us back the bucket that contains the chain. So first thing we'll do is int bucket equals internal search for key. Now we know which bucket it's in. Let's see what happens. If bucket is equal to fail, return false. Couldn't find it. Not here. All right. Now, what do we need to do? We need to scan through that linked list to find the node that contains this key and then delete it. So node prev equals null, node cur equals table sub bucket, while cur is not equal to null. This should look suspiciously familiar. Does it not? Who thinks this doesn't look familiar? Good answer. Good answer. All right. If cur dot get data is equal to, no, get key. Get key is equal to key. This is it. Delete it. All right. If prev is equal to null, what does that mean? Hmm? It's the head of the list. And if it's head of the list, we can pretty much just say table sub bucket dot table sub bucket what is equal to table sub bucket dot get next. Will that work? Yeah, that'll work. And return true. We're done. Else, prev is actually pointing to the one before the one we want to delete. All right. So this one is pretty straightforward too, right? Prev dot set next is equal to cur dot get next. Right? Is that correct? Yep. Should pretty much do it. And what do we gotta do next? Move those guys down, one along. We get to the end of the while loop, return false. We couldn't find it. Right? But we would have already done that anyways, because what's kind of cool is that our internal search, if it fails, in reality, this statement here should never ever get executed, because we would have failed way up here. We would never fail down that far. Does that make sense? First thing that's going to happen is we go searching for it, right here. If it's not here, we return false. So in theory, we should never hit this statement, because we would have known before we even executed any of this that it didn't even exist. But nothing wrong with having a belt and suspenders. Does this make sense? Yeah, okay, let's test it. Yeah, let's see how we did. All right. Guess something we probably want to do is be able to print this guy, right? Okay, so if we want to print this guy, let's get that done. Public string to string. Yeah, probably don't want to do that. For int I equals 0, I is less than table dot length. I plus plus. One thing we need to do inside this is we need to return something. Here's our return string. Inside here, the first thing we're going to do is we're going to say RTN plus equals table plus I plus equals plus, now there's a linked list there, right? So let's just do that to start, and then what we'll do is if table sub I is equal to null, RTN plus equals empty, and a new one. So that'll print an empty table. You can print it all out. That should work. All right. Else, yeah. Print the linked list. Node n equals table sub I. Yeah, pretty much right. While n is not equal to null, what are we going to do? We're going to say RTN plus equals this, and we're going to have that, and then plus and get key plus comma space plus and get data plus close that. All right. Table dot get 23. Not bad, huh? Almost like I knew what I was doing. What do you think? We covered a lot of crap. Holy cow. Hey, you know what? I didn't hear anybody snore. Congratulations. Golf clap. Which one did you want to see? Ed. Ed.
Yep.
So, key is, there's no hashing technically. I mean, it hashes whatever bucket.
Yeah, you just get the one bucket, and then it's a linked list off. All right. Homework.
I mean, these are like 7 buckets.
It is. Not the kind you can buy at those new stores in Massachusetts. Different kind of hash. I was watching the news the other day, and in the morning they were having the weather guy. They were talking about planting and all this kind of stuff, and he was talking about what's the best fertilizer to use on your marijuana plants. It's like, wow! The world has changed, okay? So this one, what you're going to do is you're going to do open address hashing, but with a key. So that's why I didn't do a key in the open address, but I did in the chained hashing. So now you can migrate this stuff over to an open address hash. I'll figure it out. And if anything doesn't make any sense, just do what you think makes sense and let me know what you did. It should be okay. String get based on the key. Put the key in the string. You check whether or not it contains, which is basically a search. You can delete based on the key, and you can print the hash table. Yeah, pretty straightforward. Questions? Covered a lot of stuff. I'll post the code. We good?
What does put do?
Put is an add. All right, get out of here. Go home. Your families are waiting for you.